Hey students, I wanted to give a graphical example of rejecting or failing to reject the null hypothesis. So for example, let's say that you had the following situation. You had a normal distribution, and here's the idea that you're basically doing when hypothesis testing. The null hypothesis is an assumption about the mean. So here I'm assuming the mean is zero point 0.6 or about 60%. So you can see this normal distribution, the mean is right there at about 0.6, okay? So that's the underlying, what we call the null hypothesis. You're making that assumption. So with that assumption of that mean and the standard deviation of 0.01, you take a sample and you get a sample proportion. And let's say that your sample proportion was 0.58, so 58%. So you took some large sample and you got a sample proportion of 58%. The question is, how likely is that sample given that assumption that the mean of the distribution is at 60%? And that the likelihood of getting a sample as small as 0.58, that's the p-value associated with that sample. So the probability or the p-value of getting a sample that small or a proportion that small is about 2.2 or about 2.3%. In other words, this is a fairly unlikely sample proportion given that assumption. In other words, all you see is this. All you see is the sample proportion. But when I get a p-value associated with that so small, it makes me think, oh, that underlying assumption of where the mean of that distribution is it makes me think that that assumption is incorrect. Now, the way you quantify that is you set a significance level. And if I set a significance level, I'm doing this problem and I set a significance level of 5.05 or 5%, that's saying whenever the p-value is less than 0.05, I'm going to make the assumption, or I'm going to reject that null. I'm going to reject that assumption, okay? So when you say 0.05, you're saying, hey, if I get a sample proportion that's that I'm only likely to get something that different from the mean 5% of the time, then that means I'm going to make the assumption that this is incorrect, that the mean is not 0.6. The mean is less than 0.6. I'm going to go with the alternative hypothesis. So I wanted to point something else out with you. I wanted to go to another curve really quick, and I want to change the mean up with you, but leave the sample proportion the same. So let me do that. Here, if the sample proportion is still 0.58, so I still have the same sample, but the underlying assumption is that the mean is 0.59. With that underlying assumption, getting a sample proportion of 0.58 or less, that occurs about 16% of the time. In other words, that sample proportion occurs fairly likely, right? Something that small occurs 16% of the time. So in that case, I'd say, oh, that makes me think that this assumption that the mean is 0.59, I have no reason here to think that that assumption is incorrect. I fail to reject the null hypothesis. In other words, I'm not going to reject the null. I'm not going to reject the assumption that the mean is 0.59. It doesn't mean that the underlying population mean truly is 0.59, but I don't have evidence from this sample to draw that conclusion like I did right here. See, that assumption of 0.6, clearly that gives me doubt because the odds of getting something that small, 0.58, getting that sample of 0.58, that only occurs about 2% of the time. Whereas if the underlying assumption that the null was 0.59, well, getting a sample of 0.58 or less, that occurs fairly often, 16%. So here I'd fail to reject the null, but here in this example, I would reject the null, assuming a significance level of 0.05.